Just a heads up. So we did letter A the other day. I think it's in the last video that we did. And I'll review it by doing another problem just like it. So we're going to do C and then we're going to go back up and do B. So remember, this is just like letter A where we had an arithmetic sequence and I wanted to find the first term, not the like 20th term, not what the common difference was. I want to find the first term. So again, if this is helpful, do it. If it's not helpful, don't do it. Essentially, I have 1, 2, 3, 4. I have the fifth number is -5 and 6, 7, 8. The ninth number is -17. So I want to figure out what my first term is. And in order to do that, I need to know what my D is, what my common difference is. Is this iPad's anybody's?
There's another one back here.
And we don't think that's ours?
Nah, I know.
Okay. I have to plug my computer in or else it's gonna die. Oh, I almost fell. That would have been really bad. Okay. Anyway, what I was getting at is in order to solve, I need to do a couple formulas in order to move forward. So I have to set up a systems of equations in order to move on from here.
Did you record the last one?
Yes.
Because I had to wait for that link to work in some type of admission office. She got my credit card and I had to wait down there for
Yeah. I think they're all recorded. I just wanted to get this one recorded. Hi, Bryce.
What's up, Ms. White?
No uniform pants for the last week?
The last week?
Yeah.
What do you mean?
Where are your pants at?
They got soap. Spilled peach cobbler juice, so I'm trying to help break it.
We can't all be heroes, can we?
No, we can't. We can't try to either.
No good deed goes unpunished.
Exactly.
Um,
Now my pants smell like peaches and apple juice. Literally.
sounds like you've had a day. Do you
But
miss-
it's been a good day because it's sunny outside too.
That's so, it's so true.
So I ain't gonna let it get me down. Ms. White.
Don't let it get
Not-
you down.
not
No,
doing
we're not doing that.
it. Not doing
All right. So on this problem,
it.
guys, I really did record this thinking this would be way better than A period. We are just as off the chain as we were in A period. I'm going to put both up, I think, and then you can decide which commentary you want to hear because we are on one in both days. But we have to write a formula for both of these, and we're using our arithmetic sequence formula. So I believe I have it written at the top of the page. It's this one. A sub n equals a sub 1 plus n minus 1 times d. So we need to use that, and we have to find a sub 1, and d in order to solve. Now, I have a sub 5. What is my fifth term? -5. So we're going to say -5 equals a sub 1, I don't know that, plus n, which is what spot am I in right now? What number of terms am I on? The fifth term, 5 minus 1 times d, which I also don't know. Okay. Now I got to do my a sub 9 term. It's my other term that I know, a sub 9. What is your ninth term? -17. So that equals a sub 1 plus, this time it's my ninth term, so we're going to do 9 minus 1 times d. If you remember from letter A, we have to simplify these, and then we're going to use eliminations to cancel out my a sub 1 so I can solve for one of my variables. So to simplify, my bottom equation just becomes -17 equals a sub 1 plus 8 times d. We'll come back. Equals 8 times d. And then my top equation is very similar. It's just 4 times d. So -5 equals a sub 1 plus 4 times d. Okay, we good with this so far? Okay, now in order to get rid of one of your variables, we are going to take all of my signs in one of my equations and switch them. So I'm going to do the top one. I'm just going to make that a +5. I'm going to make that a minus a sub 1 and a minus 4d. Then I'm able to combine because my a1s are going to cancel out. So I get -12 equals positive 4d, which means d has to equal -3. All right, now that I've done this, that means I'm minusing 3 each time that I'm going down the list, but I got to figure out where I'm starting in order to minus 3, minus 3, minus 3. You can plug pick either one of your two equations and plug -3 in. I'm just going to do the first one because it's got simpler numbers. So I'm doing -5 equals a sub 1 plus 4 times -3. That's -5 equals a sub 1 minus 12. And then you add 12 to both sides, and I get a sub 1 equals 7. And you don't have to do this, but what you can do is use these numbers to fill in the rest of our sequence so far. So we know we start at 7, and I can check to make sure this works, because if I minus 3, the next number should be 4, and then 4 minus 3 is 1, and then 1 minus 3 is, and -2 minus 3 is, ooh, that one works. Okay, minus 3 one more time. We get good. And then again, good. One more. Oh, 2 more, I guess, -14. And then -14 minus 3 is -17. So that works. So you can go back and check your work with these. Sometimes I feel like we've done a lot of math so far that we can't really check. So it's good to be able to check these. So my a sub 1 is 7. Okay. So we've done 2 arithmetic sequences. Now we need to do geometric. Okay. So we are going to go to letter B, and we are going to do this exact same thing. But instead of using my arithmetic sequence, I've got to use the green one now that has a sub n equals a sub 1 times r raised to the n minus 1. So that's what we're going to use in order to solve this next part.
Can you go back to where you solved for G? I mean, N?
Yeah. Like that.
Can you remind me when our chapter 9 test is?
It is on Friday. Today is your last day of notes, and then next class is a review, and then Friday is your test. All right, can I move on to the next one? Awesome. Okay, so this one's geometric sequence. It tells us a sub 2 equals 3 and a sub 8 equals 192. So we're going to do the exact same thing we did above. A sub 2 is 3, so I'm going to say 3 equals a sub 1 times r raised to the 2 minus 1. Now, before I go write my other equation, I can think in my head, I go, okay, I can do 2 minus 1. 2 minus 1 is just 1. So this equation simplified is just 3 equals a sub 1 times r to the first. Okay, we are not going to do elimination here. We're going to do substitution, and you'll see why that makes more sense in a minute. Let's do the other one. I've got a sub 8, right? A sub 8 equals what? 192. And so that's a sub 1 times r raised to the n minus 1, which is 8 minus 1. And so that means I can simplify it by going one more step and saying my r is being raised to the 7th instead of 8 minus 1. So 192 equals a sub 1 times r to the 7th. That's good. Yep, thank you. Bless you. All right, so again, elimination only works when you're adding or subtracting. We're not adding or subtracting, so we need to substitute. I think if I get this first one with one of the variables by itself, then I'm able to substitute into the other one. Let's get a sub 1 by itself because I don't really want to deal with that subscript if I don't have to. So we do that by dividing by r on both sides. So I have 3 divided by r equals a sub 1. You can plug that in for our a sub 1, 3 over r goes in for our a sub 1, and we're able to solve from there. So 192 equals 3 over r times r to the 7th.
Where we at?
We're on 6B of, nope, go back a few pages, a little bit more. All right, I think on the
6B.
right.
I see.
Yep. Why is it helpful to have it written like this? What can I do now that I've got 192 equals 3 over r times r to the 7th? Cancel my r's. So I've got 1 r on the bottom and I had 7 on top. So I now have 6 on top. So that's like 192 equals 3 times r to the 6th. Then what should I do? Divide by 3? Oh, sorry. What did you say? I had an r in the denominator and I had r to the 7th up here. So we've got an r in both the top and bottom. So the r's get to cancel out. R to the 7th divided by 1r means that I've got 6 r's left. So we're going to divide by 3. So 192 divided by 3, I think, is 64. Is that right? Okay. Okay, now we've got a couple different things we can do. You can start guessing and checking. You can ask yourself, okay, what raised to the 6th power is going to get me 64? If you don't know that, there's a button in the calculator that we can press too. It's 2. Now that one's maybe an easy one that we know, but in case you don't, I do want to show you the shortcut. If you hit math, and then I think number 5 says n, and then it has a radical, that means that I can do a square root to any power. So I'm going to do 6 radical 64, and it should pop out 2. If you have an older calculator, you might need to type 6 first, and then go to math, and then go to that button. But we can do a radical to any exponent if we want. So that means r equals 2. Okay. All right, now I need to find a sub 1 because my whole point is finding the first term and I haven't found the first term yet. What do I do to find the first term? Plug it back in. I suggest going up to this very last step we had a minute ago, 3 over r equals a sub 1. So that means 3 over 2 equals a sub 1.
How did you put that in the calculator?
If you go to math and then scroll down to number 5, it says n and then it says radical. Click on that. And then you should be able to change the number in front of the radical to be 6 and then change the number under the radical to be 64. Do you still have X written on your screen?
It said answer.
Oh, I might have to look at it. Anybody questions yet? How did I get what? Oh, I plugged it in. R 3 over R, and R is my.
Oh, put 6 right here.
So I plugged it back in here. Like essentially into this equation right here, but I had simplified it a step earlier to say 3 over r equals a sub 1. And if I know r is 2, then 3 divided by 2 is just 3 over 2. And so that's my answer. I won't make us multiply through and make sure that that works, but that's all that's going on there. Anybody have any questions? That is it for section 9.4. So we're going to go into 9.5 now, and I'm going to do a lot of kind of skipping around because I want to show you all sorts of different types of problems. There was no homework on 9.4. There is no homework on 9.5. The only homework you have is to start that review sheet because next class on Wednesday, we're going to work on it, and then Friday, you're taking that test. Because that's just how schedule goes. That's how the cookie crumbles. There's a lot of different types of problems on this section in this chapter, so make sure you know how to do the basics. I'll have your quizzes graded by the next class, so you can look at those to help you review, especially if there's something on there that like we think is pretty basic, we should know how to do those, okay? The one thing I didn't quiz you on is this 9495. I will give you these formulas on the test. I will give you these two formulas, and then I'm going to teach you two more in a little bit. I will give that to you on the test. Okay, perfect. All right, so we are letter D, you can do. I just don't feel like doing it. We got to get to some other problems. So we're going to jump down to 9.5 and we're going to do A, B, and C on this set of problems. Have you guys ever seen anything that looks like this?
Sideways mixed D sauce.
It is. That is a, what we call a sigma.
It's not in the shape of an S.
The sigma in the Greek alphabet looks like that. It looks like an E. Have you ever been down like Greek row? Sigma Kappa is like a common sorority.
Yeah, I was about to say like the
Yeah, like there's other sororities and fraternities. I don't know them
like
off.
Delta Sigma Theta.
Yeah, Delta Sigma Theta.
AKA.
Theta.
Mhm.
EKA. Is that what you said?
Okay.
Oh, AKA. Oh,
They don't have a sign.
That's not.
they
not
say
Sigma.
AKA though. There's no Sigma in that one. That's why I thought that she said that.
Like, that came out of nowhere.
That is a sorority. You're really right. But that's Alpha Kappa Alpha. So this is sigma. It's a Greek letter, and it represents what we call summation notation. I said this to Alpha, and they all made fun of me, but it makes me think of, did you guys see the like cartoon version of 101 Dalmatians? Where Roger, the guy with the dogs, like plays piano and he sings about having a Dalmatian plantation. Is that just too old for you? Or did I just really date myself from that? No, yes. Does anyone know what I'm talking about? Okay. Okay, thank you. You guys are all giving me blank looks. And I was like, okay, I guess nobody knows what I'm talking about. Well, every time I say summation notation, I think of a Dalmatian plantation. So it just kind of runs in my head like that. Another thing we could use instead of summation notation is the actual Greek letter sigma. So you might see me calling it summation notation. You may see it being called sigma notation. Both of those things are true. What we are doing with this, as soon as we see the sigma, that means that we are summing, we are adding together all the terms that we have here. So we're going to do some summing of these pieces. Now, the notation looks really scary, but it's not that bad. Again, the sigma means that you're summing. The one, the n equals whatever number is what we are going to start with. That's what we're going to start by plugging into my n up here. And we are going to plug in each number consecutively, 1, then 2, then 3, and we're stopping at whatever number is on the top of my sigma notation. And then we're going to add those terms together. So I'm going to do 2 times 1 plus 3. I'm going to say plus 2 times 2 plus 3, plus 2 times 3 plus 3, plus 2 times 4 plus 3. We can just keep going and going and going. Okay? So let me write those out. If you don't feel like you want to write those out, you don't have to. I'm just afraid of messing up and not writing the right thing. So I'm going to type it all out. So I'm going to physically write, okay, we'll say 2 times 1 plus 3. And I'm going to say that's being added to 2 times 2 times 3. And that's being added to 2 times 3. Oh, come back. 2 times 3 plus 3. Mm-hmm. And then 2 times 4 plus 3. Yeah, are we good back there? Oh, is there enough to share with everybody? Okay. Okay. I just think that's a little rude. We all want a snack, so. Okay, so we're going to add those pieces together. So 2 times 1 plus 3 is
6.
no.
Oh, I'm tripping. 5.
That's okay. 2 times 2 plus 3 is 2 times 3 plus 3 is
9.
2 times 4 plus 3. 11. Good. So we're going to add those all up. 5 plus 7 plus 9 plus 11 is 32. 32. Perfect. So that little summation notation just tells me my answer is 32. All right, let's do another one. Now this time on letter B, what do I start by plugging in for n? Good. And then when do I stop plugging numbers in? 6. So I have to do 2 and 3 and 4 and 5 and 6. Somebody in my last class thought that 6 meant like how many pieces we have. So they were like, oh, well, you have to plug in 7 because we started at 2. Nope, it's nothing crazy. Just you start by plugging in 2, and once you plugged in 6, you're done. So we're going to do the exact same thing again. Now, if you don't have to write this out, good on you. Again, I'm always nervous about messing something up, so I'm going to be super careful. I'm going to do 2 minus 1, 3 minus 1, 4 minus 1, 5 minus 1, and 6 minus 1. I'm going to add all of those together. And then I can think about what they are. So 2 minus 1 is 1, 2, 3, 4, 5. So I'm just adding 1 plus 2 plus 3 plus 4 plus 5. Is that 15? Awesome. All right, one more like this, all right? The next one, I've got my sigma notation, n equals 1, 4. So I'm doing 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, adding those all up together. Is that 30?
Yeah.
Perfect. Okay. So we did those all by hand. Yep, that's what you're plugging it in for. Now, the next one, which we are not going to do, this one is being raised to the 100th, but I'm going to teach you a little shortcut on how to do that in a second, okay? So let's go down. We are going to do number 2A, and we're going to write in summation notation. So the last problems I gave it to you in summation notation, we were able to manipulate it and find an answer. Now I gave you a list of numbers and we want to represent it. I want to write it in a summation notation, which means that I've got my sigma. I'm going to have n equals 1. We're always going to have that. What we have to figure out is what's going to go on top. How many times am I going to do this? And what's my expression that's going to tell me these things? Okay. And I have a shortcut, but I want you to take a minute. I want us to kind of struggle through this. Everybody's with me? Okay. So what do we think? What's going on here? What should I take note of? How am I going to represent this list of numbers as an expression? You're adding by 6? It's arithmetic. Okay, so we're adding by 6 each time. Okay, so we're going to have to deal with something with the 6, right? Okay. We need an n in here somewhere. What'd you say? Could it be 11?
Wait,
4.
We got to do a couple things before we can figure out what our n is.
I thought the N was the number on. Right?
No, my number on top might be 11, but I feel like there's a couple things we need to do before that. Why do you think it's 11? What'd you do?
Well, no, I just remember from the last time when it was already given to us the 11. I mean, the number on top was the last number was always the N.
Well, it wasn't always the number. So like, see how this was 4 and this number is 11. So like we had to do something to plug in 4 and get out 11. What do we think? What's going on? Is it like, am I just going to add n to 6? No. What am I doing each time again? Plus 6. So if I'm adding 6 each time, I think the n needs to go with the 6 to show that I'm doing that every time. Okay, so then my question to me would be like, what else do I need to do to this so that if I plug 1 in for n, I'm going to get out negative 17? Negative 7, excuse me, sorry. Negative 7. So if I said like 6 times 1, what do I need to do to that to get to negative 7? Minus 13. Why? It gets to negative 7. What if I plugged a 2 in? 6 times 2 is 12, and is 12 minus 13 negative 1? Yeah, there we go. Now, we struggled a little bit. I made you work for that, but I'm going to teach you a shortcut in a second. Before we do that, though, we have to figure out what number goes on top, and that number comes from setting my expression equal to that last number. So essentially, I'm saying, what is my n? What n did I plug in to get 53? So let's do 6n minus 13 equals 53, and let's solve for n. So add 13 to both sides. 6n equals 66, n equals 11. So Kelly, you were right that it equals 11. I think our reasoning on why it's 11 was maybe a little flawed, but you weren't wrong that 11 was there. Okay, now I've got a shortcut for you. So you're going to be mad that I made you do this all the way out by hand or by thinking it through. If I use my arithmetic sequence formula, I could have found this immediately. If I plug my a sub 1 in, what is my a sub 1 in this list of numbers? Negative 7 plus, I don't know what my n is, minus 1, and what was my d? 6. If I did just the explicit formula for this arithmetic sequence, I would have gotten 6n minus 13. Distribute my 6 through, I get negative 7 plus 6n minus 6, and then add negative 7 and negative 6, and 6n minus 13 is my explicit formula, which is that number right there. So I just made us work a little bit for it. Sorry.
I like it.
We had to earn our way there, right? Now, that being said, I want to make sure that we looked at it this way because I think it's easy to guess and check when it's arithmetic, but it's not as easy to check when it's geometric. So we're going to jump down. We're going to skip letter B. We're going to go do letter C, and that's a geometric one. And we're going to use the same concept that we had right here. Okay. So I already said this is geometric. What's my R? What am I doing each time to go from one number to the next? Negative 3. So I'm multiplying by negative 3. So R equals negative 3. Okay, I'm still doing sigma notation. So there's my sigma. My n equals 1, because it always does. Now, we don't know what my n on top is. We're going to have to figure that out. Oh, no, wait, I actually can know what it is. What does it mean if it goes dot, dot, dot like that? Infinity. It doesn't end. There's no ending number, so we're going to put an infinity on top. And we could dive a lot more deeper into that, but we're just kind of skimming the surface, knowing that infinity could go there. All right, and then we're going to use the expression that comes from my geometric sequence. So a sub n is equal to a sub 1. What's your a sub 1? Good. Times your R. What's your R? -3 raised to the n minus 1. Can you simplify that anymore? Nope, that's as good as it gets. This is my answer. All right, not a lot of work for that problem. Anybody have any questions yet? All right, we're going to skip letter D as well. And now we're going to take into account the summation notation, the one that I told you that I had a shortcut, but I wasn't willing to tell you yet. When it's being raised to a high number, I don't have to know all the terms in order to add them up. We're going to use a little formula to do an arithmetic sequence sum and a geometric sequence sum. So I'm jumping down. We're going to do 3A, B, and C, I think. And then we'll do the first 2 of 4. So what do I have? 5 more problems. 1, 2, 3, 4, 5. Okay. But in order to do those, I've got a couple equations to go over. The first 2 you already know, so I'm just going to remind you. So arithmetic sequence, I've said this, I've written it. You probably are so annoyed I'm still saying it, but I want you to know it. Arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. Okay, we knew that. It's probably written 7 times all over your paper just because we keep rewriting it. Geometric sequence is similar. A sub n equals a sub 1 times r raised to the n minus 1.
You gonna make us memorize these?
Nope. Okay. Now the 2 formulas that you do not know come from what we call arithmetic series and geometric series. That's the sum of the terms that you have. So these 2 formulas are new, and they tell us the sum of the numbers in an arithmetic sequence, or the sum of the numbers in a geometric sequence. It goes like this. Instead of being a sub n, it goes s sub n, because s stands for sum. So sum of the first this many numbers equals a sub or n over 2 times a sub 1 plus a sub n. Okay. Geometric series is pretty similar. So I'll zoom in so you can still see the arithmetic series that represents the sum. Geometric series goes s sub n equals, and this one's a big fraction. It says a sub 1 times 1 minus r to the n over 1 minus r. Okay, so each of these need different things. And as I've said, I will give these to you on your test. Series. Like a TV series almost. Okay, how are we doing? Good? You guys ready to use these formulas, these new ones? Okay, sometimes you need to use one of the 2 before it in order to use the 2 new ones. That's why I wanted to remind you of these as we're here. Okay. And I know that I'm using these because it says find the sum. Now, this first one, you're probably like, well, there's nothing here. Why can't I just add them all up and put them in my calculator? You can totally do that. But I'd love to prove to you that they work by plugging it into my formula. Okay, so I'm going to prove to you my formula works, and then we'll show that it works using the addition. So is this arithmetic or geometric? Arithmetic, good. What did I do to go from one to the other? +4, good. And that's how I would go all the way up. Okay, so this is arithmetic, so we want to use the arithmetic series. And that formula goes s sub n equals n over 2 times a sub 1 plus a sub n. Okay, I believe we know all of these pieces. How many terms are there? What is my n? How many numbers are in this list? 6. So 6 goes for my n. Ooh, that's way too big of an eraser. I'm just going to erase the pieces and just put in what I know. So n, I'm going to put in for 6. So s sub 6 means the sum of the first 6 numbers, and then 6 over 2 means that n divided by 2, n is 6. What's my first term? What's my a sub 1? Negative 7. And then what's my last term? What's my 6th term here? 13. Everybody still with me? We're all good? The 6 comes from how many pieces I have? 1, 2, 3, 4, 5, 6. All right, that's a full equation. I can simplify and solve, and that should give me the sum of all those numbers. So 6 divided by 2 is 3, negative 7 plus 13 is 6, and 3 times 6 is 18. Now, I promise I'm going to get my calculator up, and I can add all 6 of those numbers, and it should also be 18. Negative 7 plus negative 3 plus 1 plus 5 plus 9 plus 13. Uh-oh. Wish I would have noticed that earlier. 1, 5, 9, 13. Oh, and it's 18. How fun is that? It works. That's all I do. The formula is the same thing as adding up all those numbers. So what I wanted to prove to you is if I just press add in the calculator, it gets the same number I got when I did my summation formula. So, I mean, you do for the formula, but I proved it works in the calculator too. Now, if you do the next problem though, you can't put that in the calculator because there's a dot, dot, dot. So there's a bunch of numbers they're not including. So you can't just add 117, 110, 103, and 33 and expect to get the right answer. We have to use our formula here. Now, tell me, what did we do from one term to get to the other term? Minus 7. So is that arithmetic or geometric? Arithmetic. So we're doing another arithmetic series, which good thing we just used that formula. So I'm just going to recopy it. S sub n equals n over 2 times a sub 1 plus a sub n. All right, what do I know? Do I know how many terms there are? I actually don't. I'm going to actually have to find that out in a minute. Do I know what my first term is, though? What is it? Good. Do I know what my last term is? Yeah, what is it? 33. Perfect. We just don't know what my n is. So we got to go find that. We got to figure out how many times I had to minus 7 in order to get to 33. I'm going to have to go back and use my sequence formula, my arithmetic sequence formula. I have to do a sub n equals a sub 1 plus n minus 1 times d. And I have to find n. So that being said, what would my a sub n be in this case? What's my last term, or what's the term I'm looking for? 33, right? We don't know what that n is, but we know that that term that we care about is 33. So I want to figure out what spot in line it is. What's my a sub 1? 117. And then what's my d? Negative 7. Good. Could you solve that for n? Yeah. And once I solve this for n, I'm going to be able to plug n in and use that to solve. So I've got 33 equals 117 minus 7n plus 7. I can do 117 plus 7, 124 minus 7n. I'm going to minus 124. 33 minus 124 is negative 91 equals negative 7n. Divide by negative 7. And I get 13. Why is that helpful? Why did I have to find 13? Now I can solve my first equation. I got to plug that in for my n's. So all these n's become 13. So the sum of the first 13 numbers is 13 divided by 2 times 117 plus 33. 117 plus 33 equals 150. And times 13 divided by 2 is 975. Okay, we're going to do one more like that, and then we're going to do two more a little bit different, okay? This one now, those were two arithmetic series. That means it's probably time for a geometric series, right? 975. So flip over to letter C. This problem, is this geometric or arithmetic? Geometric, and what do I do to go from 5 to 15? Times 3, good. So we're going to use our geometric series. So we have to use this formula. S sub n equals a sub 1 times 1 minus r raised to the n all over 1 minus r. Now what do I have? Do I have a sub 1? Yeah, that's 5, right? Do I have r? Yeah, that's 3. Do I have n? No, I do have a sub n, but I don't really need him in this formula. But I do need him to go find n. So we actually need to go figure out what n is so that I can solve this equation. So we're going to use our geometric sequence formula. We're going to use a sub n equals a sub 1 times r raised to the n minus 1. My a sub n is that giant number, 98,415. What was my a sub 1 again? 5. And what's my r? 3. That's all I know. So let's start simplifying. What do I do first? Divide by 5. And I get 19,683 equals 3 raised to the n minus 1. Now, you can do one of two things here. The first thing you can do is guess and check. So I can say, okay, 3 to what power is going to be that number? And then I set the power equal to n minus 1. I think that's the easiest thing. Okay, what should we guess? 3 to what power might give us this big number? 3 to the what? I'm going to tell you it's not nearly as big as you think it's going to be. 9 is the right answer. Nine is actually right. You think that it's going to be something bigger. You're like, oh, I'll try 3 to the 50th. It gets so big so fast. So often these numbers aren't that big. So 9 equals n minus 1. So n equals 10. Now, what you could do is you could do logarithm. You could do a log roll and say log base 3 of 19,683 equals n minus 1. Do you remember how to put that log into your calculator? If you go to math and go all the way down, log base is the last option. And if you click on that, you can make your base be anything and you can do log of anything. And I still get 9. So that's just another way of doing it. Was logs on this semester or was that last semester? Last semester. So does that mean it's on your final?
No.
No. So should you know that? Yeah.
No.
But will you be required to know it? No. Okay. So n equals 10. I have to do that so I can plug in for this n. And this is all just throwing it in the calculator. So I'm going to do 5 times 1 minus 3 to the 10th. And then I'm going to divide that by -2 because 1 minus 3 is -2. So S of 10 is this giant number. That makes sense, right? That should make sense because we are adding this giant number to it. So there's probably a few other giant numbers being added. So it's okay to get something that crazy and that big. You often do. I've got 2 more problems to do. You guys are doing great. And I would argue this one we just did was the hardest one. Okay. The problem with the next set is it doesn't give us the last term. Instead of giving us a sub 1 and a sub n, it gives us a sub 1 and it gives us n. Now that means we're going to have to do a little bit of work in this first one. What kind of series are we talking about in this first one? Is this arithmetic or good? What'd you do to get to the next term? Plus 3. Okay, so that means we're doing our arithmetic series. And so that's this formula. S sub n equals n over 2 times a sub 1 plus a sub n. Now tell me, what do we have? What do we have? First term is -2. I have my n, which is 90. Do I have my a sub n? Oh, no, we have to go find that. We've got to find that in my sequence formula. So I have to think of a sub n equals a sub 1 plus n minus 1 times d. What was my a sub 1 here? Good. And what was my n? Good. So we're finding a sub 90. 90 minus 1. And what was my d? 3. A sub 90 equals -2 plus 90 minus 1 times 3. So -2 plus 89 times 3. 89 times 3 is 267. And then minus 2 is 265. And why do I need 265? For my last term, I have to do a sub n in my equation. So I have to do 265 in here. So 90 divided by 2 is 45. -2 plus 265 is 263. And 263 times 45 is another huge number. Is this one yours? Is it in the back of the room? Okay, you can go get it. I got 11,835. All right, last problem, last pre-calc problem ever. You guys ready?
Yes. Ooh.
Let's do it. All right, what's going on here? What'd you do to go from point 1 to point 2? Multiply by 2. All right, is that geometric or arithmetic? Geo. So we're going to use this formula, S sub n equals a sub 1. Let me try a little bit harder. 1 minus r to the n over 1 minus r. Okay. Tell me, what do I have? A sub 1 is 0.1, right? What's my r? 2. Good. So both of those r's become 2. And then what's my n? 12. Nice. I don't have to do anything extra. I have all my pieces I get to plug in, and I'm just going to throw in the calculator. Let me pull them up. I'm going to do 0.1 times 1 minus 2 caret 12. And then I'm going to divide that by 1 minus 2, which is divide by -1, which just makes it positive. Oh, I lost my decimal. I thought something was wrong. 0.1 times 1 minus 2 caret 12. And then divide by -1. Oh my God, I did it. Okay. positive 409.5. Okay. Any questions off the top of your head right now? Okay. Let me turn this guy off.